This is part 5 of a series of videos on graphing polynomials by hand. And in this one, what we're going to do is we're going to do the last step. And the last step is to actually sketch it by hand. So let's do an example. Let's see if f of x is equal to minus 2x squared, x plus 5, x minus 3 squared. So the very first step we're going to do is we're going to find the leading term. And if we look at the leading term is going to be minus 2x to the 5th. So let's think about y. Here we could multiply this all out to find the leading term, but we actually don't need to. All we need to do is look at each term. Here this is minus 2x squared. The largest power here is just a plain x. And the largest power here is an x, but you're going to square it, so it's going to be x cubed. And if you go minus 2x squared times x, that's minus 2x to the 2, 3. Oh, this is x squared, sorry. X squared, x is minus 2x to the 5th. And that's going to be like, the end behavior here is the second step. The end behavior. And the end behavior is going to be like x, negative x cubed. So that the end behavior is going to look like that. The third step is you're going to find the zeros. And if we want to find the zeros here, then the zeros will be 0, right? Because minus 2x squared equals 0 is when x is 0. Minus 5. And the positive 3. And the multiplicity of the x-intercepts or zeros are going to be 2. Why 2? Because this is a x squared. Negative 5 is going to be a 1. Because it only shows up once. And the negative 3 is going to be a 2 because it's squared. So those are your first steps. Now what we're going to do is we're actually going to graph it. And let's look at graphing that. The way that we're going to graph that is I'm just going to draw the x-intercept. Now this is just going to be a sketch. If you really wanted to graph this better, you would probably use a calculator or a computer. The way that I do this is you just kind of look at all the information you have and see what's most likely. And it turns out that we know the graph eventually looks like this and eventually looks like that. We also know there's a 0 at 0, at minus 5, and at 3. Now the key is not only are these zeros, does the graph cross the x-intercept, the x-axis, but it's the only place it crosses the x-axis. Now the important thing is multiplicity. Now the thing about multiplicity, if it's a multiplicity of 2, then you know it's a touch. And if it's a multiplicity of 1, you know it's a cross. And if you know it's a multiplicity of 2, you know it's a touch as well. So what I'm going to do is I'm going to put a little star at the 0 and 3 to remind me that those are touches or tangents. So the graph is going to be here. It's going to cross through the minus 5. And at some point it's going to turn around and come up to the 0. And at the 0 it's just going to be a touch. Why is it going to be a touch? Because the multiplicity is even. So it's going to come down and cross there and touch there. And then the 3 is also a touch. It's going to come up and be tangent. So the graph is going to look something like this. And I don't really know exactly what it looks like. But that's a pretty good sketch of what f of x is equal to minus 2x squared, x plus 5, x minus 3 squared looks like. It's not, in some ways it's not as good as if you did with a graphing calculator, but in other ways it's better. Now if it's not written in factored form, you'll have to write it in factored form, but to find the zeros. Let's do one more example, and then I have a following video, which is part 6, which we'll do a couple more examples. Let's say we have g of x is equal to minus 3x cubed, x plus 6, x minus 4 squared. First step, leading term. Leading term is, well, let's see, minus 3x cubed times x squared. So that's minus 3x to the 6th. Second step, in behavior. This is going to be like x squared, but since it's a negative, it's going to be like negative x squared. So the in behavior will be like that. Third step, find the zeros. The zeros here are 0, negative 6, positive 4. What's the multiplicity? The multiplicity here is 3. Here the multiplicity is going to be just a 1. And there is going to be a 2. And here I like to say if it's a touch or cross. Let's think about this. This one is a multiplicity of 3, so it's going to be a cross. Multiplicity of 1, so it's going to be a cross. And a multiplicity of 2, so that's going to be a touch. Now we're ready to sketch the graph. Here's your x-axis. You could draw the y-axis in, but it doesn't really add much. You have a 0 at 0. You have 1 at minus 6. Minus 6. And you have 1 at positive 4. You could use graph paper here, but you're kind of just, all you're really doing here is sketching the outline of what the graph looks like. The in behavior is down here and down here because it's like minus x squared. And then I like to put a little asterisk where the zeros are going to be tangent or touches. So let's look at the zeros again. The zeros, the only zeros that are going to be touches, the only one is going to be at the 4. So I'll put a little asterisk here. And now let's see, if we start here and we cross, then we come up like this. At some point we have to turn. This is going to be a cross, so we come down here. And then at some point we turn. This is going to be a tangent, so it's going to look like that. You can always use it in behavior. If it doesn't work out, then that means you probably are looking at it in the wrong way. It's kind of a way to double check. So the graph is going to look something like this. It's going to cross through here, and at some point it's going to turn. Then it's going to cross through here. Now here it's going to be tangent. And that's what your sketch looks like. Now the key is that this is a sketch. You don't really know how far this comes up or how far this comes down. This could just as easily go way up here, and this could go real shallow here. You don't know. But you do know the general shape of this graph. And that's how you graph polynomials by hand. If you need more help with polynomials, then you can just look at MA Class 9's Polynomials Part 1, 2, 3, and 4. If you need another example of this, just look at the following video, which is Part 6.